Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. We are from Group 5. We will present the result of our group discussion about how plants defend themselves from pathogen attacks. This is our member, Asa Tsania Khoirunnisa, 190, Mutiara Fitriyani, 192, Syilvia Rahmawati, 201, Risthriadhi Rahayu, 203, Fauziah Rahmawati, 223, Butsaina Sabilla Yassarah, 240. Pathogens of different types will attack the host in different ways. Most commonly enter the parts of plant organs like leaves, stems, roots that are infected. Bacteria attack plant tissues intercellularly, and viruses attack plant tissues by moving from cell to cell intracellularly. In general, plants will respond to pathogen attacks, and that response will be responsible for plant resistance to pathogen. As the result of an attack, the pathogen will provide a defensive reaction to protect it. Plants will defend themselves in two ways, namely structural defense and metabolic chemical defense. Definition of plant defense. Plant defense is the ability of plant varieties to limit the growth and development of certain pests or pathogens and or the damage they cause when compared to vulnerable plant varieties under environmental conditions and the pressure of pests or similar pathogens. Plants will defend themselves in two ways, namely the existence of structural properties that serve as physical barriers and will inhibit pathogens from entering and spreading in plants and biochemical response in the form of chemical reactions that occur in plant cells and tissues so that pathogens can die or be stunned in growth. The combination of different properties varieties depending on the age of the plant, the type of organs, and tissues attacked by the pathogen, the natural state of the plant, and the weather conditions in the growing area of the plant.
And then is plant structural defense. First is defense structure before pathogen attack. Plant structural defense. Plants have certain morphological structures that cause them to be infected by pathogens. These structures include the amount and quality of wax and cuticle covering the epidermal cells, the structure of the epidermal cell wall, the size, location, and shape of the stomata and lenticels, and the thick cell wall tissue. The wax on the surface of the leaves and fruit forms a water-repellent surface and thus prevent the formation of a water film so that pathogens cannot germinate, such as fungal spores or reproduct, such as bacteria. The chemical composition of the wax also affects its durability. Rice resistance to brown spot was positively correlated with the total alkane fraction of the waxy coating on the leaf surface. The first line of defense defense of plants against pathogens is the plant surface. The pathogen penetrates the plant surface in order to cause infection. These structures include the amount and quality of the wax and cuticle covering the epidermal cells, the size, location, and shape of the stomata and lenticels, and the thick network of cell walls that impede the advance of pathogens. Wax on the surface of leaves and fruits form a surface that can prevent the formation of a water-repellent layer so that pathogens cannot germinate or multiply. In addition, the cuticles can increase plant resistance to pathogenic infections that enter the host plant only through direct penetration. The thickness and strength of the outer walls of epidermal cells appear to be important factors in the resistance of some plant species to certain pathogens.
Next one, plant structural defense, defense structure after pathogen attack. Histological defense structure. Histological defense structure are associated with changes in the tissues surrounding the pathogen and can occur in various forms as follows. One, formation of the cork layer. Infection of the host by a disease-causing pathogen often causes the plant to form several layers of cork cell in front of the point of infection as a result of stimulation of the host cells by substance secreted by the pathogen. The cork layer inhibits the attack of pathogen from the beginning of the wound and also inhibits the spread of toxic substance that may be secreted by pathogen. The dead tissue, including the pathogen, is then bonded by a layer of cork and the pathogen remains at the site which form necrosis or is pressed out by the underlying healthy tissue and form a scab that may peel off directly, separating the pathogen from its host. This is an image of mechanism.
And then formation of abscission layers. An abscission layers is formed on young leaves that are active after infection by pathogens. The abscission layer consists of a gap between two circular layers of leaf cells surrounding the locus of infection. In infection, the middle lamella between the two layers of cells become dissolved from the entire thickness of the leaf, thereby cutting off the central area of infection from the rest of the leaf. Gradually, the part shrinks or wilts, dies, and peels off, and pathogens are carried in that part. And this is picture of the process. Next, telosa formation. Telosa is formed in the woody vessel of plant under stress and during attack by vascular pathogens. Telosa is protoplasma that grow abnormally from parenchyma cells that protrude from wooden vessels through holes. It could be that telosa is formed very much and quickly in the front of the pathogen so that it can inhibit the development of further pathogens. And this is picture of the process. And then precipitation of sap or planduct or gums. Various types of sap can be produced by plants around the worm by pathogenic infection. With the presence of the sap, a barrier is formed that cannot be penetrated by the pathogen so that the pathogens become isolated and cannot obtain nutrition and over time will die.
Cellular defense reaction involves morphological change in the cell wall or change originating in the cell wall attacked by pathogens. However, this defense mechanism has limited capabilities. There are three main types of cellular defense structure, namely, 1. Swelling occurs in the outermost layer of the cell wall accompanied by a fibrous substance or amorphous that can prevent bacteria from multiplying. 2. Thickened cell walls in response to several types of viral and fungal pathogens. And Cellosa palpilla deposit on the inner side of the cell wall in response to an attack by pathogenic fungi.
Cytoplasmic defense reaction. In some types of cell attacked by the pathogenic fungi, the cytoplasm and nucleus enlarge. Cytoplasm becomes granular and hard and appears various particles or various forms in it. Finally, the pathogenic mycelium decomposes and the infection stops.
Necrotic defense reaction. Necrotic defense reactions are mainly found in disease caused by obligate, parasite, virus, and nematodes. The necrotic defense reaction, also known as the hypersensitive defense reaction, is a blind defense reaction in the form of rapid cell death in and around the affected cells due to necrosis. Pathogens and living tissue can be isolated by necrotic tissue. This is picture of necrotic defense reaction mechanism. According to claimant in Trinayanti 2012, defense reaction occurs when the pathogen touch the protoplasm. The mechanism of the necrotic or hypersensitive defense reaction is that after the plant is attacked by pathogens, in the process of infection, the cell wall will be penetrated by the pathogen. The pathogen will move toward the attack of the pathogen after the pathogen is in contact with the protoplasm and will immediately disintegrate or break and have a round shape and brown color in the cytoplasm. When a color change occurs in the cytoplasm to brown and eventually dies, the invading hyphae begin to degenerate.
The next, plant metabolic or chemical defense. Chemical defense before pathogen attack. In general, the defense of plant that play more role is chemical defense or metabolic defense. Inhibitor released by plant into the air, into their environment. Plants secrete various substances both from plant part above the ground and through the surface of their roots. Some substances released by plant have inhibitory power against certain pathogens. Inhibitor or substance released are phagocytotoxic exudate. Exudate that plants secrete at the roots to call or attract beneficial microbes or repel harmful microbes. Root exudate will select microbes to associate with secreting cannabinoid compounds, which are toxic. The formulation of antifungal compounds called phytoanticipin produced by healthy plants serves as a barrier to the presence of pathogenic fungi.
And then is defense in the absence of the essential factor. This form of defense includes four things, namely, first, there is no recognition between host and pathogen. Certain plant species or varieties may not be infected by pathogen if their cell surface doesn't have a specific recognition factor that can be recognized by the pathogen. If the pathogen does not recognize a plant as one of its host plants, then the pathogen may not attack the plant or it may not produce infectious substance. Second, deficiency of host receptors and sensitive parts to toxins. In the combination of the host pathogen, the pathogen usually produces a specific toxin in the host. The toxin is responsible for the symptoms that will be product and react with a specific sensitive site or receptor site in the cell. Only plants that have receptor or sensitive parts become sick.
Next, no essential nutrients for pathogens. Plant varieties for several reasons product an essential substance for survival for obligate parasites so that these varieties are resistant to pathogen attack. An inhibitor present in plant cell before infection. Several phenolic compounds and tannins are present in high concentration in young leaf or fruit cell and are thought to be responsible for the resistance of these young tissues to pathogenic microorganisms.
Next, lack of receptor and host sensitive part to toxin. Certain varieties of our plant species for some reason produce an essential substance or one of the essential substance to survive for obligate parasite so that the variety is resistant to pathogenic attack. For example, Risthriadhi to be able to infect a type of plant requires substance from the plant to form hepipets, and hepipets will be form penetration hepae which is then used to infect plants. If the plants do not provide the substance needed, then hepipets are not formed so that infection will not occur, that the plants become resistant. In artificial media, fungi generally cannot form hepipets unless the purebred and added extract are vulnerable houseplant and not resistant houseplants.
Plant metabolic chemical defense. Chemical defense after pathogens attack. Plant produce biochemical inhibitors in response to pathogenic damage. Plant cells and tissues react to damage, whether caused by pathogens or mechanical and chemical agents, through a series of biochemical reactions aimed at isolating the disorder and healing the wound. These reactions are often associated with a fungi toxic reaction around the wound site as well as the formation of a protective layer of tissue such as callus and cork.
Defense through hypersensitivity erection. In the process of pathogen infection, the pathogen penetrates the cell wall after the pathogen is in contact with the protoplasm. The nuclear cell moves towards the pathogen attack and immediately disintegrates or breaks and becomes round brown in color in the cytoplasm. When the cytoplasm turns brown and finally dies, the invading hepae begin to degenerate. The necrotic tissue will isolate the obligate parasite from the surrounding living substance so that it can cause the pathogen to die. This picture is defense for hypersensitivity reaction. Hypersensitivity response is the response of plants to infection by fungi, virus, and plant pathogens. Hypersensitivity is a plant defense complex, which is the initial response to limit the movement of pathogens in the form of necrosis and cell death. HR occurs When pathogenic bacterial cells are introduced into non-host plant tissues such as the pathogen Pseudomonas syringae. In tobacco, when an avirulent pathogenic strain was introduced into the host with the major resistance gen, was found to be effective against real isolates such as the monospore isolate of the photovoltaic Chickpea pathogen. On Passaros progressively red mixation, beans or brown rice are dried over red beans. In Clement 109, 1971, define three-stage space against bacterial pathogen. 1. Induction phase occurs when bacteria are present in the intercellular space. The afferent gen is activated in bacteria and the afferent gen product is directly delivered to the host cell via a special secretory mechanism. 2. Latent phase. 3. Percentage or collapse phase is occurs when the host cell in the inoculate area collapse and dries, turning silver and then yellowish.
And then defense struck increased level of phenolic compounds. Phenolic compounds can be found in both a healthy and diseased plant. In resistant plant, phenolic production is more and faster. When plant interact with other pathogen, compounds that can inhibit the development of pathogen will be formed by plant as a reaction to pathogen invasion. The metabolism of phenolic substance occur in plant in response to injury or invasion by pathogen. Phenolic compounds from resistant plant will inhibit the growth of pathogen more strongly than in vulnerable plant. Phenolic compound from resistant plant will inhibit the growth of pathogen more strongly than in susceptible plant. The accumulation of phenolic compound can lead to an increase in the phenylalanine ammonium lyase or PEL in enzyme and the synthesis of the cytinase enzyme functionally to function in plant resistant. After infection in resistant varieties, the increase in level of phenolic compound will occur more quickly. So the conclusion is plant defense is the ability of plant varieties to limit the growth and development of certain pests or pathogen and or the damage they cause when compared to plant varieties that are susceptible to environmental condition and pressure of similar pests or pathogen. Plants will defend themselves in 2 days, namely the presence of structural properties and biochemical response. Traits that serve as a physical barrier and prevent pathogen from entering and spreading within the plant. Biochemical responses in the form of chemical reactions that occur in plant cell and tissues so that pathogen can die or their growth is inhibited. The combination of defense properties varies depending on the age of the plant, the type of organ and tissues attacked by the pathogen, the state of plant nutrients, and the condition in the area where the plant grows.
Okay, if you have any questions, please discussion in our group. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.